Have you ever wondered how something goes viral seemingly overnight, or how you get the timing for an event, just right? Well, today, we're going to unlock the secret language of numbers to figure out how massive growth and perfect timing actually work. And trust me, it's way simpler and more useful than you might think. So just think about these two questions for a second. On one side, you've got this explosive, almost out of control growth. And on the other, you need this perfect, repeating, clockwork precision. They feel like completely different problems, don't they? Well, it turns out there's a common mathematical toolkit that handles both. Okay, let's really dive into this. Picture it, a social media post just exploding online. The numbers multiplying so fast it makes your head spin. Then, picture a festival where the lights need to sync up perfectly with the beat. These aren't just abstract ideas, right? They're real-world puzzles, and we can solve them. Let's start with the first one, that problem of massive scale. To get a handle on that kind of viral growth, we need a very specific tool. It's called a power, and it is the absolute key to taming gigantic numbers and making them, well, manageable. So what is a power? Honestly, it's just a brilliant shortcut for repeated multiplication. Instead of writing the same number out over and over and over again, we use this really neat, compact little form that's built from just two simple parts. So first up, you have the base. That's the number we're actually multiplying. You can think of it as the what. And then you have the exponent, which is basically the repeat button. It just tells you how many times to multiply the base by itself. Simple as that, the what and the how many times. Let's just walk through a quick example. If you see 3 to the power of 4, our base is 3 and our exponent is 4. That just means we multiply 3 by itself 4 times. So 3 times 3 is 9, times 3 again is 27, and one last time gives us 81. See? So simple, so clean, and incredibly powerful. Now here's where it gets even cooler. Once you start working with powers, you find out there are even more shortcuts. These are called the laws of indices. And by the way, indices is just the plural word for exponents. These rules make calculations ridiculously fast. All right, here's the first one. Let's say you're multiplying two powers and they have the exact same base number. You don't have to do all that long, messy multiplication. Nope. You just add the little numbers up top, the exponents. And this is the official formula for it. What's so amazing about this rule is how it takes a potentially huge, complicated calculation and just turns it into simple addition. It's a really elegant piece of math that just cuts through all the complexity. Let's see it with some real numbers. Say you have 7 squared times 7 cubed. Since the base, the 7, is the same, all we do is add the exponents, 2 plus 3. And the answer is just 7 to the power of 5. No complicated math needed at all. And, as you've probably guessed, if multiplication has a shortcut, division does too. If you're dividing powers with the same base, you just subtract the exponents instead. And there's the formula. It's the perfect partner to the multiplication rule, right? Instead of adding, you subtract. It's this kind of consistency that makes these rules so powerful and actually pretty easy to remember. For instance, 4 to the power of 5 divided by 4 squared. The base is 4 in both, so we just do 5 minus 2, which is 3. The answer is 4 to the power of 3. So, the main point here is that these rules simplify everything, and they let you handle massive numbers without breaking a sweat. Okay, so we figured out how to tame huge numbers. Now let's switch gears and go back to our second problem, the festival lights and the music. For problems that involve timing and sharing, we need two totally different tools, the lowest common multiple and the greatest common factor. The lowest common multiple, which we usually just call the LCM, is exactly what we need for that festival problem. If you have two things happening on different cycles, the LCM tells you the exact moment they'll sync up again. It's literally their next meeting point. Now, the greatest common factor, or GCF, is for a different kind of puzzle altogether. This one is all about breaking things down. Say you have different amounts of things, and you want to bundle them into identical groups with nothing left over. The GCF tells you the absolute biggest number of groups you can possibly make. So here's the absolute key difference, the easiest way to remember it. You use LCM for things that repeat over time. When you're asking, when will these things happen again at the same time? The answer is almost always going to be a bigger number. You use GCF when you're splitting things into groups, when you're asking, what's the biggest number of identical sets I can make? And that answer will be smaller. All right, we have our tools, we've got powers for handling growth, and we've got LCM and GCF for timing and sharing. So, I think it's time to actually solve those puzzles we started with. First up, the festival. The lights are on a 6-second cycle, the music is on a 9-second cycle. We're looking for their next meeting point, so this is definitely an LCM problem. So, we list out the multiples of 6. You've got 6, 12, 18. Then we do the same from 9. You've got 9, 18, and boom! The first number they share is 18. And that's our answer. They sync up perfectly every 18 seconds. Okay, now for the sharing problem. We've got 20 cookies and 24 brownies, and we want to make the most identical gift bags possible. This just screams GCF. So we start by finding the factors, all the numbers that divide evenly into 20, and then all the numbers that divide into 24. Now, what's the biggest number you see on both of those lists? It's 4. That's it. You can make exactly 4 identical bags, and each one will have 5 cookies and 6 brownies. Perfect. So, why does any of this really matter? Well, because these aren't just abstract math puzzles you do in school. Powers help us make sense of everything from how money grows in a bank account to how populations expand. And LCM and GCF, they help us plan events, schedule our lives, and share things fairly without any waste. These are truly practical, powerful tools for understanding the world around us. And that really brings us to the end. The next time you see something that's growing fast or repeating or needs to be shared equally, you'll actually have the secret language to understand it. So the only question left is, what everyday puzzle will you solve first? Thanks for tuning in.